James Webb Space Telescope was built to do something extraordinary, to look back to the very beginning of time and answer one of our oldest questions. It was designed to catch the first faint flickers of light that broke through the cosmic dark ages, the very first stars and galaxies. For decades, the story we told ourselves about the universe's beginning was one of slow, gradual awakening. But some of the first deep glimpses from Webb have left scientists scrambling. The galaxies it found weren't faint, they weren't small. Some were shockingly bright, massive, and looked surprisingly mature. It was like finding a fully grown adult in a cosmic nursery, and it suggests the first chapter of our universe was far more dramatic than we ever imagined. This is the story of how Webb's journey into the past is forcing us to rethink our own cosmic origin story. To get why Webb's findings are such a big deal, you have to understand its mission. The telescope is, put simply, a time machine. Light takes time to travel, so looking at objects billions of light years away is literally looking billions of years into the past. Webb's powerful infrared eyes were built specifically to see the ancient stretched-out light from the first few 100 million years after the Big Bang, a period astronomers call the Cosmic Dawn. Before this dawn, the universe was in the cosmic dark ages. After the Big Bang, the cosmos was just a hot, thick fog of particles. As it cooled, it formed a vast, dark sea of hydrogen-neutral gas. There were no stars, no galaxies, no light. It wasn't empty. It was a universe just waiting for someone to flip the switch. So what were we expecting to find? Our leading theories painted a pretty clear picture. Over hundreds of millions of years, gravity would slowly clump the densest patches of gas and dark matter together. First stars, these hypothetical giants that astronomers call population 3 stars, would ignite. These would be simple stars made only of pure hydrogen and helium from the Big Bang. From these tiny seeds, the first small proto-galaxies would slowly form, merge, and grow. The process was expected to be slow and steady. Webb's job was to find the first signs of this gentle awakening. Instead, it found a cosmic riot. In 2024, a team of astronomers pointed Webb at a tiny patch of sky for a program called the jwst Advanced Deep Extragalactic Survey, or JADE, and there it was, a little red smudge that would challenge everything. It was named JADE's GSZ140. After using Webb's near-infrared spectrograph to carefully analyze its light, they confirmed its incredible distance. We were seeing it as it existed just 290 million years after the Big Bang, when the universe was barely 2% of its current age. At the time of this confirmation, it shattered the record for the most distant galaxy ever seen. But its distance wasn't even the most stunning part. It was the galaxy itself. According to the slow and steady model, a galaxy this early should be a faint flicker, just getting started. Jade GSZ140 was the opposite. It was astonishingly luminous, shining the brightness that suggested it packed a mass of 100 million suns. It wasn't a tiny starter galaxy, it was a substantial object, already about 1,600 light years across. The first question was whether this intense light was just coming from a giant black hole at the center, gobbling up gas, but the data suggested otherwise. The most straightforward interpretation was the light coming from a massive population of brilliant young stars. This kicked off a huge debate in astronomy. How on earth does nature build a galaxy so bright and so big in less than 300 million years? It was a serious challenge to the established timeline. The universe apparently was in a much bigger hurry than anyone thought. The mystery of Jade's GSZ140 only got deeper when astronomers took a closer look with another telescope, the ALMA array in Chile. What ALMA found added a bombshell to the puzzle: the clear chemical signature of oxygen. This was a huge deal. Right after the Big Bang, the universe only had the lightest elements: hydrogen, helium, and a little lithium. Every heavier element, from the oxygen we breathe to the carbon in our bones, is forged inside stars and can only spread across the cosmos when those stars die in massive supernova explosions. Finding oxygen in a galaxy just 290 million years into cosmic history was wild. It meant that somehow a whole generation of massive stars must have already been born, lived out their short parallel lives, and exploded. And then a second generation of stars had to form from the newly enriched gas. the very stars Webb was seeing. This entire life cycle happened on a timescale that was previously thought to be impossible. The galaxy wasn't just big, it was already surprisingly enriched with heavy elements. The simple gradual story of cosmic evolution was officially in trouble. This also complicated the search for the long sought after population 3 stars, the legendary first lights of the universe, made of pure primordial gas. In one of the earliest galaxies we've ever seen, Webb was already finding stars made of recycled materials. It suggests that if the first population 3 stars existed, they must have been formed, lived, and died even faster than our models ever predicted, leaving behind these chemical ghosts for Webb to find. These discoveries are unfolding right now, reshaping our cosmic story in real time. Well, do these discoveries mean that the Big Bang is wrong? Not at all. The overall model of an expanding universe is stronger than ever. But it does mean that theories about how the first things in that universe form are missing a key ingredient. Scientists are now racing to figure out what that is. One of the leading ideas is that the early galaxy formation wasn't slow, but bursty. Instead of a gentle simmer, the early universe might have been a pressure cooker, with some galaxies going through incredibly intense and efficient bursts of star formation. Perhaps the explosions from dying stars weren't as good at clearing out gas as we thought, allowing these baby galaxies to hold onto their fuel and bulk up at an incredible rate. Then there are the more out there ideas, but ones that scientists are seriously considering. One fascinating though speculative hypothesis is the existence of supermassive dark stars. These aren't stars powered by nuclear fusion, but theoretically by the annihilation of dark matter particles at their core. These objects have grown to be millions of times more massive than our Sun, shining with an incredibly light that might explain the brightness of some of these early galaxies. It's a wild idea, but it could potentially solve two mysteries: where the extra light is coming from, and how the supermassive black holes we see today got their start. The James Webb Space Telescope was sent to see the universe's baby pictures. It was supposed to find faint, simple structures just beginning to glow at the end of a long, dark age. Instead, it found a cosmic landscape already buzzing with activity. It found galaxies that were shockingly big, bright, and complex for their age. Like Jade's GSZ 14-0 aren't just record breakers, they're paradigm shakers. They show us that the infinite universe was far more capable of building grand structures than we ever give it credit for. We thought we were showing up for the crack of dawn, but it looks like the universe had been awake for a while, already building its first cosmic cities. Each new image from Webb peels back another layer of the mystery, forcing us to ask new questions and embrace a more chaotic and frankly more interesting story of our origins. We're left staring into the past, wondering, are we seeing the signs of a completely new cosmic process, or is there just a crucial piece of the puzzle we haven't found yet? Whatever the answer, the journey to find it has only just begun.